Okay, we're going to talk about inverse functions, finding the inverse of a function, but with restricted domains. Sometimes we have a naturally restricted domain based upon the function's characteristics, and sometimes we just have to give a restriction on the domain in order to make it one-to-one. So I'll start with this particular problem. F of x equals negative the square root of x minus 3. Well, this is a one-to-one function. If we graph it, we know it's kind of our right eyebrow, but it's kind of actually our right bag under the eye because it's negative. So when we look at it like this, we could say this is going to be shifted 3 to the right. It's a square root function, so it's 3 to the right. But instead of going up, I go. So when x is 3, this will be 0. And when x is going to be 1, or sorry, when x is 4, 4 minus 3 is 1, the square root of 1 is going to be 1, but it's going to be negative, so it's going to be down here negative 1. And then if we go over here, 1, 2, 3, 4 will go down 2. You can't really see that on the graph, but it would look like this. Now we want to graph that so we can actually get a good feel for the domain and the range, because that's going to be important when I determine my domain and range of my inverse function. So my domain here is going from 3 to infinity. It starts at 3, so it's closed at 3 to infinity. And use the interval notation because it's going to be easy to flip these for the inverse function if you keep it in interval notation. And the range is going to be from negative infinity up to 0. So it's going to go from negative infinity to 0. Oops, and it'll be closed at 0. All right? So there's your domain and there's your range. Okay, kind of went over this little T-chart I have on these particular graphs. Sorry about that. Okay, so we know that for our inverse function, the domain and the ranges just flip. And that's going to be the main reason why we do this, so we can make determination when we get the inverse function. So here the domain will be negative infinity to 0. And here the range will be 3 to infinity. So if you write these in interval notation, it's a lot easier. Rather than saying x is greater than 3, then this is going to be y is greater than 3. So that's where that might be a little confusing to flip the x and the y's. So if we just write the interval notation, it's real easy, just flip them. So 3 to infinity, that'll be the range. Okay? And negative infinity to 0, that's going to be the domain of the inverse function when we figure that out. So let's take a look at that. Let's figure that out over here using our four-step process. So first thing, okay. So number 1 over here, we let y equal f of x. So f of x equals negative the square root of x minus 3. And then we interchange the x and the y. So x equals minus the square root of y minus 3. And then we have to solve that. So number 3 will solve for x. The first thing I can do is I can square both sides. I can write it down again. And I want to get rid of this radical, and I can actually do this in one step. It doesn't really matter what you do with the minus sign in what order, because it'll work out either way. So we can just square both sides. And we end up with x squared on the left equals the square root of y. I'm sorry, just negative times a negative is a positive, and the square roots become the same. When there was a square root of y minus 3 times the square root of y minus 3 is just y minus 3. Oops, so don't do that. That just becomes y minus 3. I think I got my white out here. So a negative times a negative is a positive, and then the square root of y minus 3 times the square root of y minus 3 is just y minus 3. And then I'll add 3 to both sides. And I end up with x squared plus 3 equals y. And my fourth step is I call that f inverse of x. So f inverse, try to do that in green. F inverse of x equals x squared plus 3. All right? The only problem is if we start with a one-to-one function, we take its inverse, we should have a one-to-one function. So if I look at this over here and I graph this is just going to be my parabola, but it's going to be shifted up 3 units. It's going to look like this. It's going to start here. I'm going to go over 1 up 1, back 1 up 1, over 2 up 4, back 2 up 4, and it would look like this, which is not a one-to-one function. All right? So that's my f inverse of x. That's going to be x squared plus 3. But that's not, I'm sorry, it's an inverse, but it's not a function. It's not one-to-one. It's not an inverse function. It's an inverse. It's not a function. So we have to decide which branch we're going to use. In other words, we can either look at the left branch or the right branch. In other words, that part would be one-to-one, or that part would be one-to-one. Okay? So how are we going to do that? Well, this is where we look at our domain over here. Now the range won't really help us because the range is 3 to infinity for both branches. From this branch and this branch, the range goes from 3 to infinity. But look at the domain. The domain goes from negative infinity to 0. So that means the domain of my inverse function has got to be this branch. So I can just cross this out over here. And that's what we've got. So we have to basically put this restriction on the domain on our inverse function. So that means that x is going to be less than or equal to 0. So we can put that over here. All right. And then if you graph them both on the same axes, just to check for the symmetries, my inverse function is up here, 3, goes up to 4 about this, so it'll look like this. And my original function, this is f inverse, you label it. And my original function f was over here. And then if you look at those relative to that line y equals x, the diagonal line that goes through here, this is the line y equals x. You can see the symmetry. Looks really nice. Okay, so I want to be aware of how these work analytically as well as graphically. This is the analytical part over here. And this is our graphic part over there. Okay? And again, if you use graph paper, it's a lot easier because you're going to get a much more exacting graph of both these functions. Okay? So I hope that all makes sense. Go back and check it over and make sure you understand how to deal with these inverse functions with restricted domains.